So now that we know that matrices are just a way for you to set up your information, we have to get a little bit of vocab under our belts. Every matrix has what are called dimensions. So the dimensions of a matrix are going to be written in the notation rows by columns. So it's one of those things where I think I just have to kind of show you what it means to be a row and what it means to be a column. Because orientation, obviously, you know, if you turn your head, you think of it differently. But everyone in matrix land thinks of this top right here. This is a row. So like this guy here is row 1 all the way across here. And this is row 2. So rows measure this way. So that leaves columns to be vertical, just like columns in a building. So this is column 1. This is, oops, this is column 2. Oh, pen. Column 2, and this is column 3. So columns measure from top to bottom. So when I go to first figure out if I can even perform the operation on the matrix set, I have to make sure that the dimensions work for the situation. So if you're adding and subtracting matrices, you need them to have the exact same dimensions. So for instance, this guy has 1 row and 2 columns. So his dimensions are 1 by 2. And then this matrix also has a 1 by 2 dimension. So since they have the same dimensions, you're allowed to add them, and the resulting matrix is going to be a 1 by 2. Now how you add them, it's pretty self-explanatory once you see the first one. You just add the comparable parts together. So 6 plus 3 is going to go in our 1, 1 position, which is 9. And then negative 2 plus 1 goes right there, negative 1. So then the next question, the dimensions are the same, but just for practice, let's talk about what the dimensions are. So how many rows are in this next example? 2 rows. And then how many columns are in this one? 3 columns. And this guy also is a 2 by 3, so which means you're going to be able to subtract them this time. And then the resulting matrix will also be a 2 by 3. So each one of these positions that I'm kind of putting blanks down for, they represent a component of the resultant matrix is what we call it. So like this is position 1, 1, this is position 1, 2. You don't have to write this part down. This is position 1, 3. This is position 2, 1. This is position 2, 2. And this is position 2, 3. All those position markers tells you what row and what column it's in. That becomes really, really important when we get to multiplying. So for adding, we realize these aren't really that bad. You just kind of add the things together. So add all the pieces. Let's just do the top row first. Or so we're not adding, Abruzzo, we're subtracting. Doesn't that say a subtraction down there? So negative 1 minus negative 6 would be a 5. And then 2 minus negative 5 will be a 7. And then negative 4 minus 3 is negative 7. And then similarly, you're going to subtract all the other pieces. I'm just going to look at the bottom rows now. Negative 4 minus negative 2 is negative 2. Negative 3 minus 6 is negative 9. And then 1 minus 4 is negative 3. So adding and subtracting matrices is not really that complicated, we see. Obviously, you got to subtract carefully, but adding shouldn't be too bad. So let's take a look at something more pre-calc-y. Here we go. Some people, the minute they see a matrix question, like they reach for their calculator. And obviously the ones we just got done doing, which could have been done on the calculator, I just don't think it's worth your time, guys. It's not that hard to add a few numbers together. You're going to find out soon, if you haven't already had experience with matrices, they're a pain in the tushy to type on your calculator. So if you don't have to grab your calculator, you're going to be happy. Because these, while it is nice that the computer will calculate it for you, it's very irritating to enter them. So when I'm looking at number 3, be careful. This is an entry to that matrix, this is an entry, and this all of that is one more entry. So this matrix has dimensions 1 by 3, as does this matrix. So we are going to be able to subtract them, and the resulting matrix is also going to be a 1 by 3, but notice how very large I just made that. So you're going to have some pretty intense entries into this matrix, because we have some algebra. All right, let's start with 4zx, and then you're subtracting 2y. Now, none of those are like terms, so I'm just going to write that down. for zx minus 2y. That's position 1, 1. So similarly, you have negative 3x, careful on this one though, minus y plus 5. You have to think about you're subtracting everything in the second matrix, including the 5. So when you simplify that expression as best you can, you get negative 3x minus y minus 5. And then you're going to have a similar issue here on the last entry. X minus 5z minus a negative 1. You're going to want to simplify that minus negative 1 part. So you get x minus 5z plus 1. So that is most definitely an example that you can't use your calculator for, and I wouldn't expect you to, because it really wasn't too bad to do in your brain. These are the kind of questions they like to put on SAT tests and ACT tests, because these are the questions that truly indicate whether the child understands what a matrix is doing. If a child has no clue what a matrix is, they're going to select some very odd answers. Yes?
So when we put them in our new,
the resultant matrix?
Yeah.
Yep.
They're not connected at all.
Right, so there are 3 separate positions in the matrix. So there's a 1, 1, a 1, 2, and a 1, 3. Very good. Yep, so we're going to see some applications of matrices coming up on, probably starting tomorrow, and then going into Thursday. And you're going to see, like, they're pretty basic application ideas, but the idea, like, there's one example coming up that I remember where it's an inventory list of here's what's in our back stock room, and here's the delivery shipment we just got. So if you think about, like, let's say you work at a store that has 7,000 products, like, you're not going to sit there with a checklist and go, okay, how many pairs of jeans size 3 did you get? And then, like, add them up that way. Everything's going to be entered into a system, a matrix, and then the computer's going to compile everything together. So that's the example that we're going to get, a very basic example of, like, here's my store's inventory, here's what was just delivered, and your job is to add them together. You don't really understand from the problem, because it's a real basic one, like, what all those entries represent. But if you worked at the store, you would know that position 1, 7 represents all of my size 2 blue jeans. Okay, so that's how matrices are used, and they are used in that respect. Good question. All right, let's look at number 4. What are the dimensions of that first matrix? How many rows do you see? 2 rows, then 3 columns, and then this dude is 1 row by 4 columns. So right away we have a problem. They don't have the same dimensions. So this is, you can either say the word undefined, or I usually have you guys write does not exist by writing DNE. You cannot create a resulting matrix by adding those two. Which is good news. That means no more work on that one. All right. New vocab word here. When you throw a number in front of this matrix, what does your gut instinct tell you to do with that 3? Multiply everything by a 3? Yeah, and that's actually right. This is called a scalar multiple. And again, this is another one used a lot in stores inventory. So if you need to triple everything, you would multiply everything by a 3, and this is how you would signify it on a matrix. So your resulting matrix is going to have the same exact dimensions, except all the entries in this matrix are going to be tripled. So you got -6, 9, -3, and 3. Ta-da! There's a question coming up on our practice and on our tests that say, like, here's all of your products, and you want to mark everything up by like 25%. So we're going to talk about how you can use that scalar multiply idea to mark everything up 25% higher. All right, this guy is a, well, even with a scalar multiple, it's a 1 by 2. And this guy is not. So are you going to be able to subtract these two matrices at the end? Nah, so I'm not going to bother doing anything here. This does not exist. You can also say undefined. That's another okay way to describe that. All right, this is, yes? The scalar multiple is not separate from the matrix. So it's actually a component to the matrix. They're just, at the moment, it's factored out of the matrix, but you can easily put it back in. Yep, good question. All right, so this is a good pre-calc question, also a very good test prep question. These are the kind of things they like to ask, because again, you're going to have to know something about matrices in order to figure out what they want you to do here on number 7. So they have Oh, and I think there's a couple questions that were changed on your notes, so have we run into that situation already and I just ignored it? There's like some handwritten like variables snuck in some problems. It's not, so far so good. Okay, good. So on number 7, this is your resultant matrix, and they're telling you you found that by taking -3 and multiplying it by this original matrix y. So your job is to figure out what y is. So just think backwards with me, guys. Instead of multiplying by -3, what if we divided all of them by -3? So if I kind of go backwards, dividing this by -3 would have been a -1. Dividing that by a -3 would have been a -4. Dividing that by a -3 would be a 7. And dividing that by a -3 would also be a 7. So that was the original matrix y. It was applied to a scalar multiple of -3 was applied to it, and then it got the resultant matrix that you see here. So just like you would solve an equation, you're doing inverse, well, I should say opposites. We'll use the word inverse later. All right, so this one is an adding question where you are supposed to figure out the original matrix if I give you the resulting matrix. So I know matrix B is going to look just like this first matrix, a 1 by 3. Let's figure out what those missing pieces are. So 1 plus some mystery thing gave you a 5. So that must be a 4. 0 plus some mystery component gave you a -3. So that must be a -3. And then 6 plus some mystery component gave you a 7. So that must be a 1. So they're not at all difficult questions mathematically. It's all about, do you understand the notation of a matrix and how they work? All right, this is where a lot of my college algebra kids are like, I'm just going to grab my calculator. And your pre-calc teacher's going to say, no, don't. You have to know how to do these by hand for the reasons we already discussed, okay? So if you are on a test, though, or a homework assignment, and you don't feel like you need to practice these by hand, by all means use your calculator. But I do remember number 10 was changed, right? Isn't this a B or something? Okay. So when I sneak a variable into your matrix, calculators are off limits. You cannot use your calculator in those cases. So why don't we go ahead and practice how to do this by hand. Before you can actually execute a multiplication problem, though, which is what this dot means, you have to check that you can even multiply them to begin with. So here's the rule for multiplying matrices. So let's say we have matrix A times B. What you have to check are the dimensions of A and the dimensions of B. So I'm going to call the dimensions of A rows of A by columns of A. And then right next to that, you're going to write the dimensions of B, which would be rows of B times the columns of B. And this is how you check to see if it's even defined in order to multiply them together. If these middle two numbers here match, then that means it's okay to multiply them together. Now, once you verify that those middle two numbers match, that the columns of A match the numbers of rows in B, the leftover dimensions, these are the dimensions of your resultant. Okay. So first you got to check that it's possible, and then once you verify yes, then you know the dimensions of what your answer is going to be. That's really important, because then what you're going to do is you're going to write down a skeleton for your new matrix, and then we're going to have lots of fun. I don't know how I'm going to do this in a recording, because I got to stand up at the board. Maybe I'll just shout at my microphone, I guess. All right, so let's see this in action, guys. What are the dimensions of this first matrix? Rows by columns, so it's 2 by 3. And what are the dimensions of my second matrix? Rows by columns, so 3 by 1. So to check that you can even multiply them together, you got to make sure these middle numbers match. Do they match? Yes. So that means that you get to multiply them, hot dog. And then the other thing I know, right here, that the resulting matrix is going to be a 2 by 1. So what you're going to do now is you're going to write a skeleton for a matrix that is 2 rows by 1 column. All right, this is where it gets kind of crazy. You need to circle, or somehow box in, the rows of the first matrix. You can highlight them if you have colors, that works too. And then you're going to do something similar with the second matrix, but you're going to circle their columns. So in this case, we only have the one column. All right. YouTube, I hope you can hear me. Everyone, left hand, pointer finger, ready? Point at the first row. Left hand, pointer finger. Right hand, pointer finger, point at the column, the only column you have. Start at the beginning. What you're going to do is you're going to multiply and then slide. And then you're going to multiply and slide and multiply. Add all those numbers together. Oh boy, that's a lot of mental math. Ready? Help me out. What you got? 0 plus 0 plus negative 20. What's 0 plus 0 plus negative 20? Negative 20. Write it down in 1, 1. That was first row, first column. All right. Now we need second row, first column, which is the only thing left. Pointer finger ready. Pointer finger ready. Here we go. What you got? Negative 16 plus 0 plus 30. What's negative 16 plus 30? 14. Write it down in position 2, 1. That's it. That's it. Super fun. All right, so I need to write those down. What were they? Negative 20 and then positive 14? Okay, very good. So, I know some of you have been trained to grab the calculator right away. I know that wasn't super fun because you had to do a lot of like little kid problems and hold things in your brain, which is always awful. So if you're in a jam on a test or you're really bad at holding mental math in your brain, just write them down as you get them. Like 0 plus negative 20. Nothing wrong with that. You're going to have to simplify, of course. I'm going to show you how you can do that on the calculator. And then hopefully you're going to agree with me that sometimes it's just not worth it because they're kind of a pain. So go to your calculator. And there's a matrix menu. It's right above what's called the inverse key, x to the negative 1 power. Right above that in blue should say matrix or whatever color your calculator uses. So, second inverse is the matrix menu. Within the matrix menu, you have a choice of just using a matrix, calculating some things, and then editing matrices. So unless you're using a calculator that someone from the last class already entered them for you, you're going to have to edit a matrix. So go over to edit. And this does overtype. So if you already have something there, you're just going to have to overtype and you submit by hitting enter. So the first matrix in that question we said was it a 2? I think I have it still from the last class. Is it a 2 by 3, right? Okay, so you're going to change the dimensions, if they don't already say this, to 2 by 3. You hit enter to hop over. And then it's going to open up a 2 by 3. And then you start entering things in position 1, 1. I'm going to warn you, it goes across the rows and then it loops back. So start entering all those entries into your matrix until you get what I have. Now remember, that was just your first matrix. So now you have to go back to the matrix menu, and you have to open up another matrix to edit. So probably B would be smart. So back to the matrix menu, go over to edit, and then edit matrix B. It was a 3 by 1, and then edit your entries that way. So all you've done right now is just entered the matrices into your computer. You still have to multiply them. So once you have your matrices entered, then you got to go to your home screen. And you have to pull up matrix A times matrix B, if that's where you put your matrices. So back to the matrix menu. This time you just want to pull up the name of matrix A. And then hit a multiplication sign. And then the name of matrix B. And then blammo, there's the answer. Really cool if you don't feel like doing any thought whatsoever. But how annoying was that? Like, to type. And that was only like those are small matrices. So I'll be honest, guys, My mental math's not super awesome all the time, but my laziness overrides my fear of mental math, basically. So I'm like, it's actually easier for me to do this manually. So I often, if they're smaller matrices, will just choose to do them manually because I hate typing on the calculator. But you young people, you type all day long. You probably don't care. All right, so look at the next question. We changed it a little bit. There's now a variable stuck in it. So I don't care whether you like calculators or not. You can't use your calculator this time. So first thing we better check, can we even multiply these together? So the dimensions of the first matrix are a 2 by 2, excuse me. And then this guy is also a 2 by 2. So the inside dimensions match, which means yes, you can multiply them. And then the outside dimensions that are left over, also 2 by 2. So your resulting matrix is a 2 by 2. So what I need you to do, is write like a skeleton of a 2 by 2, but I need you to make it pretty big. It's going to have some algebra fun in it. All right. This, because it's a pretty large matrix on my screen, what I'm also going to do underneath the little blanks, I'm going to write what position in the matrix we're at. So this is first row, first column. That's called position 1, 1. If that ever comes up in your math future, that's 1, 1. So this is first row, second column, so that's position 1, 2. This is second row, first column, so that's position 2, 1. And this is second row, second column, it's position 2, 2. Here's why that's important, guys. Maybe you don't want the whole stinking matrix. Maybe you just want one position. This tells you which row and which column you're supposed to be using for that particular position. So like, let's say, and this is actually how it works in real life, you have like a 100 by a 100 matrix. Are you going to want to calculate all of those components, even on a computer? No, it's going to take forever, and you have to sift through all the information. But if you know you need position 5914, that means you need row 59 and column 14, and you can just compute that one component. So kind of understanding where the matrix pieces are coming from is helpful when you go on in matrix land. All right, so circle the rows of your first matrix. Those are the rows we're using on that first guy. And then you're using the columns of the second matrix. Circle the columns on the second matrix. All right, I gotta go point again. Point and shout. Here we go. Ready? Oh. Left hand pointer finger, top row. Look, first column. Start multiplying. What you got? Negative 18 plus negative 5b. That's what that is. So write it down. Negative 18. I'd probably write down negative 18 minus 5b. But whatever. So that was position 1, 1. Alright. It doesn't really matter where you go next, guys, but I'm just going to go first row, second column. So I'm going to be filling out position 1, 2. Here we go. Multiply for me. Negative 36 plus 25. What's negative 36 plus 25? Negative 11. Okay. Write that right here. That was first row, second column. Alright, now I'm on second row, first column. So point at the second row, first column, start multiplying. Negative 3 plus 3b. Write that down. Negative 3 plus 3b. And you're in second row, first column. And then, second row, second column. Negative 6 plus negative 15. Negative 21? Okay. Write that down. Second row, second column. And I forgot every single one of those, but that's okay. I can calculate it real fast. Negative 18 minus 5b. Negative 36, negative 11. Negative 3 plus 3b. And negative 21. Yep. Yes. Awesome. So calculator's neat, but probably not where your investment should be for these questions, okay? I'll be honest, the ones we've given you to do aren't really that hard to do by hand. In fact, one would argue much easier to do by hand, and probably not worth your time to do on the calculator. Now, when we get to the augmented matrices on our next lesson, where I encourage you to use your calculator, that's because the option to do it by hand is awful. All right, so this next one, dimensions, got to check them first. Number 11 has 3 rows by 2 columns. And then your next matrix has 1 row by 2 columns. Can you even multiply these together? No. Which is good news, because that means we're done. Move on. You can say it does not exist. You can say that this matrix operation would be undefined. You can just say a big no. That's fine. Oh, I'm kind of hoping this one's a no, but I think it's a yes. We have 3 rows by 2 columns. We have 2 rows by 1 column. Wah, wah. All right, so it turns out, yes, you can multiply these. And the resulting matrix is going to be a 3 by 1. You're going to want to make this matrix pretty large. Got some algebra in your future. 3 rows, 1 column. All right. Definitely not one that you can do in your calculator. There's a lot of variable work going on here. I need you to circle the rows of your first matrix. And then we're going to take the column for the second matrix. All right, here we go. Starting with row 1, column 1. I have, oh boy, positive 6AB. So if you're not so good with the mental math like Mrs. Abruzzo, you're going to write everything down that you say. Positive 6AB plus, now you can write down 4BA, but we'll come back to this entry in a minute because that actually simplifies. All right, this next row, second row, first column again. So we have positive, whoops, come on Abruzzo. Positive 12A squared B. Oh, pen, don't do this. Hate this pen. All right, positive 12A squared B plus A to the third B. When you multiply those together. Whew. All right, now we're on the last row, row 3, column 1 again, because that's the only column. Positive 30B, and then plus AB. So the only thing that you can make prettier is this top entry, this 1, 1. 6AB plus 4AB, better known as 10AB. So that's the only thing you could have simplified in that matrix. Everything else stayed gross. So your resulting matrix is officially 10AB and then 12A squared B plus A to the third B, ugh, and then 30B plus AB. Yuck. All right, that was fun. So yeah, you do have to know how to do them by hand. They're not super fun, I know. Okay, this is super awesome though, a determinant. And we only threw this on your lesson because once upon a time we made you calculate inverses by hand, and in order to do that you had to know how to find a 2 by 2 determinant. So originally we were thinking, oh, let's just leave it off the curriculum because we're not going to have you do inverses by hand anymore. However, we have stumbled upon questions on standardized tests recently where they asked children to calculate the determinant. So we thought we'd leave it in the curriculum just for vocabulary's sake, especially since finding a determinant is super easy. I mean, it's on the calculator. If you guys go to the matrix menu and then go over to math, there is a determinant option that says DET. Now, you'd have to enter this guy as a matrix, a 2 by 2 matrix, to find the determinant. So if this was on a calculator test, you could do it that way. But guys, these are actually super easy to do by hand. In order to find the determinant, what you do is you take your left diagonal and you subtract your right diagonal. Let me show you what that means. Your left diagonal would be this guy. And you're supposed to multiply these diagonal numbers together. So -2 times 3 is -6. And then you're going to subtract the right diagonal, which would be this guy, which is -10. And then you just got to compute that number. So -6 minus the -10 is 4. The determinant is 4. So, I mean, yeah, I could have saved us 30 seconds of not learning, but at least now you know the vocab word of determinant and how you could find it by hand if you had to. So here, and I think this problem is changed, isn't it? It's 4A. All right, there we go. So this is one where we could not do it on the calculator, and I have actually seen this exact style question on an ACT test fairly recently. So The left diagonal, still a negative 6. And then you're going to subtract the right diagonal, which is a little more exciting this time. It's a 12a. Now, as far as algebra goes, you can't simplify that anymore. So that is the value for the determinant. Those are the kind of questions standardized tests love, because again, it truly will separate the child who knows what a determinant is versus the kid who's just making a good guess. Okay? All right. And then this one, there is a way to find inverses by hand. We're not going to bother. So I'm going to show you how to do this on the calculator real quick. I need you to enter this matrix into your calculator. You can enter it anywhere you want. I'm going to enter it into matrix A. And remember, your matrix is going to overtype. Whoops. So if you go to the matrix menu and you edit, I'm going to go matrix A. First thing you're going to do is change the dimensions to 2 by 2. And then enter. Now I don't have it in front of me anymore. What's the, well, here. 2, 1, 3, 2. All right, check. Okay. So once you have that matrix entered somewhere in your edit menu, back in the home screen, you need to pull up that matrix. Oh, man. And then the way to take an inverse on a calculator is just to use your inverse button over here. Ta-da! There's the inverse. It's actually not terrible to do by hand, but we felt like you guys didn't need to know that in your lives right now. 2 by 2s aren't bad. Other ones are terrible. And I will warn you that there are some matrices that you cannot find the inverse of. So if you ever try to find an inverse of a matrix and it says something like error, something about dimensions, that means the inverse does not exist for that matrix. It's not invertible. So that would be a trick question, and it does sometimes show up on your homework. So if you tried to find an inverse and it said an error, just say does not exist. All right, lesson done.